In this video I will show how to solving heat transfer and specific heat problems. And this is the equation for heat, mass, temperature, and specific heat capacity. So the equation for heat is equal m times c times delta T. And the equation for mass, it's the Q, which is heat, divided by delta T times C, which is specific heat capacity. And here's the equation for temperature, which is delta T equal to Q divided by m times C, which is mass times specific heat capacity. And here's the equation for specific heat capacity. So we are going to divide Q by delta T times m, which is mass. So let's start with solving heat problems. How many joules of heat are required to raise the temperature of 550 grams of water from 12 to 18 Celsius? So here, our Q is equal to X, or unknown. M, our mass, is equal to 550 grams. C, or specific heat of water, is equal to 4.184 joules per gram. And delta T, or the changing in temperature that happened in this problem, is 6 Celsius. Why? Because the temperature of water, it goes from 12 Celsius to 18 Celsius. So we have extra 6 Celsius added to the 12 Celsius. So it's 6. How we do the equation? We will do it like this. Q equal to 550 times 4.184 joules per gram times 6.0 Celsius. And the heat, it will be 13,794 joules. Let's do number 2. How much heat is lost when a 64-gram piece of copper cools from 375 Celsius to 26 Celsius? The specific heat of copper is 0.38452 joules per gram. Place your answer in kilojoules. Here, our Q, or heat, is equal to X, or unknown. M, or mass, equal to 64 grams. C, or specific heat of copper, equal to 0.38452 joules per gram. Delta T is equal to 375 minus 26. We'll have 349. But it's negative. Why? Because we are losing the temperature. So, or the temperature is decreasing from negative from 375 into 26. So we lost negative 349 Celsius. And here's the equation. 64 grams times 0.38452 joules per gram times negative 349. And we will have negative 1588.6. So this is joules, and they are asking for kilojoules. How we are gonna find it? We are going to find it by divided by 1000 joules. Why? Because 1 kilojoule is equal to 1000 kilojoules. So negative 8588 divided by 1000, and we will have negative 8.6 kilojoules. Now let's do number 3. The specific heat of iron is 0.4494 joules per gram. How much heat is transferred when a 4.7 kilogram piece of iron is cooled from 180 to 13 Celsius. So here we are losing the temperature too. Remember, you must use the same units, so you'll have to convert your mass to grams before you begin. Here, our Q or heat is unknown or it's X. And our mass, we are going to make one step before we put the number. So we have 4.7 kilogram times 100 times 1000 grams, we will have 4700 grams. And C, or specific heat of copper, is 0.4494 joules per gram. Delta T is equal to 180 Celsius minus 13 Celsius, and we will have negative 167. Why? Because we are like losing the temperature. So we lost about 167 Celsius. And here's the equation. 4700 times 0.4494 joules per gram times negative 167. And we will have negative 352,734.06 joules. Now we are going to do a different equation, and we will look for mass. So, question number 4. 8,750 joules of heat are applied to a piece of aluminum, causing a 56 Celsius increase in its temperature. The specific heat of aluminum is 0.9025 joules per gram. What is the mass of the aluminum? Here we are looking for mass. So our Q, or heat, is equal to 8,750. M is X, or unknown. C, or specific heat of copper, equal to 0.9025 joules per gram. And the changing in temperature, or delta T, is equal to 56 Celsius. And here's the equation. M equal to 8,750 joules divided by 0.9025 joules per gram times 56 Celsius. And the answer, it would be 137 grams. Now, let's start doing more problems. So let's do number 5. Find the mass of a sample of water if its temperature dropped 24.8 Celsius. So here we are losing, or like it's the temperature dropped, so it's negative. When it lost 807 joules, here we are losing the heat also. So the heat of water is negative 870 joules. Or mass is unknown. Specific heat of water, like usual, is 4.18 joules per gram. And the delta T is negative 24.8. So here's how we are going to do the equation. Negative 870 joules divided by 4.18 times negative 24.8. And our answer, it would be 8.39 grams. This problem was easy. Let's do number 6. How many grams of water would require 92 no, 92.048 kilojoules of heat to raise its temperature from 34 Celsius to 100 Celsius. Remember to change units first. So we have a heat about 92.4048 and they are asking us to change the units. We are going to do the same way we did in the other questions or other problems. We are going to multiply it by 1000. Why? Because a kilo joules is equal to 1000 joules. So 92.048 times 1000 and we will have 92,048 joules. The specific heat of water, like always, it is 4.18 joules per gram. Delta T is equal to 66. Why? Because we are going up from 34 to 100 Celsius. And here's the equation. It looks like this. M equal to 92.48 joules and divide by 4.18 joules times 66. And the answer, it will be 333.65 grams. Thanks for watching. In the next video I will show more types of problems.